Okay, good evening everybody, at least to me it's evening. Let me put this here. Today I want to talk to you about Advent of Code Day 18 and more specifically what I did for today's challenge. I streamed this morning. I had to quit when I had to go pick up the girls from school. And I wasn't done yet with part 1 because I got, well, not so much stuck, but I was trying to figure out how to work out how to calculate all the millions and trillions of paths. While doing so, let me bring up my here. Let me see. I shared it a bit before. I was running. Can I share this? Let's see. Open with. Okay, here. So what I found was I started to write some code and just start from 1 permutation and 2 and just see if I restrain it, what happens. And what you can see here is that for the first step, there are 600 unique combinations, 15 combinations, because we have 15 valid targets, 15 points that have a positive flow, right? Because we only consider the ones that have an actual flow rate above 0. So what I started to do was, okay, these are my targets. I calculated all the shortest path between those and A, our starting point. And from there out, I started to look, okay, if I just have 1 permutation or just 1 valve that I can visit and turn on, what is the best option there? So that turns out to be MN for my input. And that gives a score of 600. Okay, now let's say we can do 2 valves. Which ones are we going to do? Turns out IJ to NA in that order gives the best result with 965 results. Interesting. 3 permutations, you turn into 2730 options, and you see CO to IJNA, and you can see that this part here stays the same, but there's a new one that comes in front. Yeah. We move on further, and we see that one is added to the back. So this strain stays the same. Cool. 5 permutations. Another one gets added to the back. So it's like, this looks kind of familiar. And then we have a path where one is added in between, KF, but still like the order and the items that are used are preserved. So it's like, that's cool. So what I did here was, first I tried to just take at 4 permutations. So like, okay, I'll take the value that we have now because I see it repeated over and over again. I'll just take those 4 and make sure that I get new permutations for longer lengths because we still have moves left. And just generate the options after it, because this seems like the perfect start, right? It started to form at step 2 and then it stabilized at step 3 and it just keeps adding stuff. So it seems fairly stable. So I did that and then I didn't get the right answer. So it's like, okay, you know what? I'll just brute force the entire thing and see what the answer is, because I was curious. I saw this pattern and then it didn't work out in the end. So it turns out after 7 steps, once you move to 8 possible valves that you can visit, the first one changes. So this whole thing stays stable, but then one is added in the front. So I asked a friend for another input, because what I observed here is that at a certain point, a stable chain will form, and more or less the order is guaranteed, but stuff might happen in the middle, right? So what I tried to do was be clever at first and just take these 4 stuff and take that as an absolute start. But it turns out it can shift a bit. So at any point in your chain, new entries can jump in. So it's like, okay, let's write a permutation set of code that can do something like that. So I went in and I first did permutations with fixed. So this will generate permutations with a fixed start. I think I already deleted that version. And then I have a permutations with mandatory in order. Yeah, I need to find out new names, but basically what this does, it gives you your list of stuff you want to permutate. It gives you the desired length, and it gives you a list of items that are required to be in the result in the order that they are supplied. So this might look a bit complicated, but it's not that complicated, because basically it checks how many free spots there are to fill up. So we have our fixed list of items that we need to use, which is called mandatory in order here. So let's say those are 4 items and we want to build a permutation of length 6. That means that we have 2 indices that we need to fill. So I built a list of indices. Other languages can do .range and just generate that, but I just did it by hand here. So these are all the indices inside your result from 0 to length -1, because we wanted a length of 6, so it's 1 through 5, because that are the possible places where you can insert something. And then we need to get pairs of indices that we can use to generate the permutation. So the first and the second index, so 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, and then 1, 2, etc. So this one will generate all the possible combinations of where you can insert your new values. And this will just build that set. So let's say you have ABCD, and that is the set that you need to reuse. Then it can add something in front of it, after the A, after the B, after the C, or after the D. And this will take care of that. So why did I do that? Because, as I said, I noticed a pattern that you can somehow get a sort of stable chain forming when you do this. So how does that translate? This was my brute force that took 14 minutes, I think, yeah, 14 minutes to work out. And you can see best result 1862. That is my input. When I do this, and I probably should just zoom out a bit, because it's just so much code and there's so much noise in there yet. There is a solve step and another solve step, and it's very verbose now so that I can show you everything that happens. But basically I have a few input files here, and I got some from people because I wanted to test stuff. I used a Python script from the solutions thread on Reddit just to make sure that I have the exact values that need to happen so that I can validate my solution. So I checked out for each of those what are the part 1 and part 2 answers, and then I tried to see how far does my algorithm need to go in order to get good answers. So there was one input file that was really easy, that just lets me start doing this process of taking, let me see where I have it here, of taking the path that is forming as your mandatory steps and order at step 2. So you can just start at 2 permutations, take that and just keep adding 1 new permutation and build up the chain like that. There are others that are more complex, like this input file requires me to start at 4 permutations for part A or part 1, and for the second part it needs 5 permutations to get the proper chain started up. So it's not foolproof. There is no blanket way to do this. You could just set everything to 5, and so far it works on the input files, except mine. So that is cool. I just realized that part 2 doesn't work for my input file. And that's probably because, let me just run this and show you. Let me show you what it does. So this is my code, and I set it to start just taking 1 new set of permutations after step 2. So it does step 2, and I've built it here so that just every step so that you can see it happen. So after step 2 it will just add a small set. So for every new link that it needs to do, it just checks between 40 and 65 characters, as you can see here. So for the part 1 code, it actually just checks 827 options. So that's very much more optimal than anything that I've done before. and then for some reason the part 2 doesn't work out. So if you see here, part 1 1862, part 2 2414, the actual values needed to be 1862 and 2422. And I think that is because I do the calculations in order. So I first do part 1, I can show you here. The actual solve is here, and it's still a mess that I need to clean up. Let me zoom in a bit. So for part 1, I take all the options. Targets is just a hash set of all the valve names that have a positive flow. The max steps is 30 in this case. This is my pathfinding thing that will give you a direction from each point to each point of interest. And this is the step at which it can start to fold in its previous results. So in this case it's 2, as configured up above. And what I do for part 2 is do the same, except I lower the max steps to 26. And I just do one run, then I take all the paths that are used in that run and I exclude them from the total set, and I use that as a set for path 2. And this works brilliantly for all the other files that I got to test except mine. So, and that's probably because there is a way to do a suboptimal part 1 that gives a better result for the second run. And I still need to think about how I will figure that out. But yeah, if you're lucky, and it seems like there are quite a few files out there where this works for. So let me just say, if I override this, I already shown this one. This is the complicated one. So if I run this one, you see that the answers should be 1460 and 2117. And you see that it comes up with that right here, and it, how many permutations did it check? 66,400. So this is the worst case out of the files that I have that it works for. And the other ones are way less, and it still runs pretty fast. So you can see here that it starts the chain, and what you can see is at okay, it starts with YS, then it does YK to YS, so it adds one in front. Then it adds DB afterwards, and then at the 4th step, which is why I configured it to only start doing it for this file after step 4, it starts a whole new chain because that gives a better result. So after that, the chain stays stable, and you can see that it added ZR at the end, then GU at the end, and then YS, but I don't think this one is used because it didn't get enough steps to open it. So this is the final path, but if there were more steps, it would go to YS to get a better result there. So you can see the chain stabilize at permutation 4 here, which means that for this case, it needed to check just a whole bunch of things. Then for step 5, for the second file, let me see. It was the same story because it's the same process it follows. But for the second part of the run, you can see that the path changes here at step 5. And that's something that I've seen before, is that it can actually insert as well. But in this case, it just doesn't do this and then switch to a different end step. So it has to go to step 5 here for this one. And then it also comes up with the correct answers. And one more file just to show. And this one was the simplest one. It should come up with 1822 and 2602. And this one runs at, the first one needs to run to permutation 3, and then the second one can start right away because the first one is actually the path to take. And this one does just under 6,000 permutations just to check it all. So yeah, I was really happy to see this, and I had a lot of fun coming up with this. It's not perfect by any means, but it was very fun to write, and it was pretty cool to figure this out. So let me just run my own part 1 right now, because I still haven't submitted yet, though I think it should be correct. Let's see. So that should be this. So let's go and submit my part 1 now. Boom, 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 boom. Where is even my file? Here. Okay. Woohoo! So yeah, part 2. You're worried that even with an optimal approach, the pressure released won't be enough. What if you got one of the elephants to help you? It would take you 4 minutes to teach an elephant how to open the right valves in the right order, leaving you with only 26 minutes to actually execute your plan. Would having 2 of you working together be better, even if it means having less time? Assume that you teach the element before opening any valves yourself, giving you both the same full 26 minutes. In the example above, you could take the elephant to help you as follows. I'm actually wondering what it does for the test input. Let me do that. Part B, it does negative. That is funny. Yeah. So this clearly shows why this doesn't work, by the way. Because it exhausts all the options in one go. So you can clearly see here why this doesn't work for all the inputs, because the sample input doesn't. So I would have to rewrite this so that it alternates all the steps and simulates that better. So yeah, I might do that, but not today. So I'm just going to leave part 2 open because my code didn't come up with this answer. So I will probably rewrite that maybe after tomorrow's stream, but I don't know if I'll have time. And then I'll rewrite this to work for that as well. Let me see, did it come up with the right answer for part 1 actually for the test case? 364. Did I do something wrong here? Let me see. Solve test. I don't do this input overflow here. I should have done that here. Never mind. So I get that value there. I'm curious to see. Because I start too early here probably. I'll need to debug this later. dbjhee. I don't even remember what the answer was here. 1651, okay. So this also doesn't work for the test input. Oh no, it does, but it requires me going up to 5 permutations before I can do the smart thing. So yeah, as you can see, it's far from foolproof, but it was a funny way to test this. And so far, if you set the values to 5, it seems to be safely coming up with all the right answers so far, except for the one where you do them in sequence and not in parallel or like at the same time. So I will take a look at that and do that as well. But yeah, this has been fun. So I still need to clean up the code and rewrite parts of it to do part 2 in a different way. But I had a lot of fun figuring all this stuff out. So yeah, I hope you enjoyed it as well, and join me again tomorrow for another day. Bye bye.